So what we have here is an object that I'm going to turn into a dipole. This end, I want one end to become positive, one end to become negative, and I would like to see what happens to this dipole when it is in the large electric field that this Van de Graaff can make. So how do I do this? Well, first I get this ready, holding it against this stand like this, and then I turn the Van de Graaff on. And when the Van de Graaff is on, what is happening? The Van de Graaff is becoming positively charged, and that will induce a negative charge at this end and a positive charge at that end. The positive charge of the Van de Graaff is going to suck electrons from this side over to that side through the conducting rod of the stand. And now I'm all set. I'm going to turn the belt off while keeping the Van de Graaff charged. And I now have a dipole in an electric field. And if you watch, as I walk this around, the silver end is always being attracted towards the Van de Graaff because the silver end is the negative end of my dipole. It's swinging around a little bit, but if you notice here the silver end is towards the Van de Graaff, and if I come all the way around like this, when I'm over here, the silver end is towards the Van de Graaff again. And if I come all the way around here, the silver end is towards, now it's really swinging around, but you can see the silver end is being attracted towards the Van de Graaff. It's feeling a torque, which is trying to turn it so that the silver is pointing towards the Van de Graaff. If I go all the way around here, same thing. The silver is pointing towards the Van de Graaff. And now for fun, let's try and do it in the opposite direction. So I will discharge that, and I will put this back on the stand, but this time I will have the copper pointing towards the Van de Graaff. I want to show you that it is not the silver paint that's being attracted, it is actually the electric charge. So let's turn the Van de Graaff on. Now the Van de Graaff is charging up. The Van de Graaff is getting positive. That will be, this time it's going to make the copper end negative and the silver end positive. So I'm ready now. I will turn the Van de Graaff off. And this time I have my electric dipole in an electric field, and this time the copper end is attracted towards the Van de Graaff because the Van de Graaff is making the same field as before, but now I've changed the sign of my dipole. This time the copper end is negative, so it's the copper end that is being attracted towards the Van de Graaff. And if I walk it all the way around to the far side, it's always the copper end that's being attracted towards the Van de Graaff. Always the copper that's being attracted towards the Van de Graaff. Last time it was the silver, this time it's the copper, because last time I charged the silver negative, and this time I charged the copper negative. So this gives you an intuition for the behavior of an electric dipole in an electric field. You can see that the electric field is making the dipole line up with the field, because if you think about the field lines coming out of this source of charge, the field lines are pointing out like this, and the dipole is lining up with them. There we go.